All right, so for solving right triangles, the objective is to use trigonometric ratios to find angle measures in right triangles and to solve real-world problems. All right, so they want you to find, in this example, which angle, 1 or 2, is the cosine of A. So use the given trigonometric ratio to determine which angle of the triangle is A. It's obviously not going to be this one, because you never look at the right angles. So what I would do first is figure out what 24 divided by 25 is. And that's about 0.96. So the cosine of A equals 0.96. So I need to figure out if the cosine of angle 1 is 0.96 or the cosine of angle 2 is 0.96. SOHCAHTOA tells us to do cosine adjacent over hypotenuse. So I'm going to look at angle 2 first. So cosine of 2 tells me to do adjacent over hypotenuse. So let's do angle 1 first, because that makes sense. Angle 1, we have adjacent is 1.4. Again, we should be getting pretty good about naming so based on angle 1, this is the opposite, this is the adjacent, this is the hypotenuse. So based on angle 1, we have the adjacent as being 1.4, and we have the hypotenuse as being 5. Put this into your calculator, you get 1.4 divided by 5 is 0.28. So cosine of 1 equals 0.28. So we can probably make a guess that angle 2 is what cosine of A is, but let's go ahead and check that to make sure that we're doing it right. All right, so cosine of 2 equals adjacent over hypotenuse. The adjacent is 4.8, and the hypotenuse is 5. 4.8 divided by 5 is, in fact, 0.96. So the cosine of 2 is 0.96. So that means A is angle 2. All right, same thing. Tangent of A is 1.875. Is it going to be 1 or is it going to be 2? Something that you might want to think about is that the tangent of A is a number bigger than 1. So my fraction is going to be opposite over adjacent. SOHCAHTOA, tangent is TOA. Opposite over adjacent means if this number is bigger than 1, then this number has to be bigger. The O has to be bigger than the A. So if I look at angle 1, the opposite is 27, and the adjacent is 14.4. So this is going to be 27 over 14.4. This is tangent of 1. If I look at the tangent of 2, opposite over adjacent is 14.4 over 27. This is very close to about half. If I look at 14, and this is almost like 28, 14 over 28 is half. So it's probably not going to be this one, but let's go ahead and check in our calculator. Let's do tangent of 1 is 27 divided by 14.4. That gives us 1.875. And this is going to give us 14.4 divided by 27 is going to give us 0.5333 repeating. So the tangent is at angle 1. A is right here. So again, 9 times out of 10, when you have a tangent, it's either going to be a whole number or a number bigger than 1 or a number smaller than 1. If the number is bigger than 1, then the opposite is the larger number. All right, lesson 8.2, you learned that the sine of 30 degrees equals 0.5. Conversely, if you know that the sine of an acute angle is 0.5, you conclude that the angle measures 30. This is written as sine. This should be sine to the negative 1 as an exponent of 0.5 equals 30. So basically what this is saying is, last section we learned that if we typed in our calculator sine 30 degrees, we get 0.5. What now this is telling us is that if I hit, instead of, what if I don't know the 30 and I'm trying to figure out what the angle measure is? What I do is I put in inverse sine of 0.5, and then that will give me 30. So go ahead and write this table down. Your first buzzword is inverse. If you know the sine, cosine, or tangent of an acute angle measure, you can use the inverse trigonometric functions to find the measures. So again, this is what we were using last time. Now we're going to be using this. So they gave us the angle was like, let's say 30 degrees or 60 degrees. We found what the decimal point was. Now they're going to give us the decimal point, and that we're going to find the angle. Or they may give us the two numbers and we have to do opposite over adjacent or something like that and find it. So go ahead and do these problems. These boxes should say similar. Okay, go ahead and do these in your calculator. Again, if you're not getting these answers, circle your work or put a star by your buzzword so you remember to ask to make sure your calculator is working correctly. Once you have changed it, if it wasn't working correctly yesterday, hopefully we have fixed it and it's good to go now and we don't have to worry about it. If not, maybe your calculator switches it back to radians every time, but it needs to be in degrees. All right, using given measures to find the unknown angle measures or side lengths of a triangle is known as solving a triangle. So that was the objective. That's the title of the chapter. So that's what we're going to be doing. To solve a right triangle, you need to know two side lengths or one side length and an acute angle measure. So let's find this. Find the unknown measure. Round lengths to the nearest hundredth and angle measures to the nearest degree. So we've got 6 things going on. We've got angle S, angle R, angle T, side SR, side ST, and side SR. Let's put answers next to ones that we know. We know angle S is 90. We know SR is 5. And we know SRT, we know RT is 5.7. So we need to find angle R, angle T, and angle S or side ST. I'm going to do the side first because that's just going to be a simple Pythagorean theorem. ST is going to be A because it's the shorter side. A squared plus B, hypotenuse is 5.7, so B is going to be 5, equals 5.7 squared. So A squared plus 25 equals 5.7 squared is 32.49. Subtract that from 25. I get A squared equals 7.49. All right, so now I need to find out what ST is. So I take the square root of 7.49 and I get A, let's take the square root. A is about 2.7367864, blah, 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 blah. But they told you round lengths to the nearest hundredth. So I'm going to go to the hundredth spot. Hundredth is right here. I look past the line at 6. 6 tells me to go up. So this rounds up to 2.74. All right, so I'm going to fill this in as 2.74. All right, now I can find these angles. So now we're going to do the inverse. So I want to find R. I want to find the measure of this angle. So using SOHCAHTOA, I can find angle R. I'm going to go ahead and use tangent. I need to find the tangent of R is opposite over adjacent. So if I look at R, the opposite is our 2.74, and our adjacent was 5. .74 divided by 5 gives us 0.548. So tangent of R equals 0.548. But that doesn't tell me what R is. So this is where the inverse comes into play, because now what I'm going to do is do the inverse. So when I did it on my calculator last section, I did the tangent of some number, and I put in a number, and I found out this. So let's say tangent of 30. If I put in tangent of 30, I got this decimal. Now what I'm going to do is I'm going to use my inverse, and I'm going to do R equals the inverse tangent of 0.548. So let's do that. Inverse tangent 0.548 is going to be about 28.72. So this will round up to 29. They told us to round it to the whole degree. All right, on your calculator, it is very likely that your inverse tangent, the button that looks like This is the same button as your tangent. You just have to put like a second button or a shift button. So make sure that you can do this. Make sure that you know how to do inverse tangent of 0.548. And make sure that you get 28.722744128. And then when we round to the whole degree, we get the 29. All right, so let's move all this fun stuff out of the way. I'm going to bring this back up. So angle R, we said, was 29. Okay, so now what I can do is I can either do the tangent of t, or I can do the sine of t or the cosine of t, either one. Or what I can do is just realize that I have two angles. So now that I've got two angles, I can just subtract them from 180 and get that t is 61. Okay, so these are your angles and sides. Your answer is the ones that you didn't have. They gave you S, they gave you SR, so this right here would be your answer. These are the three things that you did not know, that you now do know. That was a 5-minute problem. How long did that take? All right, so that was method 1. The other method, this is the method that I'm going to suggest we use, because this was the way easier way to find the side length, using the Pythagorean theorem. The other way that we could have done this is we could have done all of our sine and cosine and stuff like that. So I could have found that the cosine of R, or cosine inverse of 5 over 5.7 was 29, and then figured out that t was 61 because of the three angles of a triangle being equal to 180. And then what I could have done is I used that fact to find, this was 5.7. This is now 29, and this is now 61. What I could do now is say, okay, well, here's R. Now I could find this, which is the opposite. I could do tangent of R equals opposite over adjacent. So this is the method 2. This is a little more difficult way to finding the side length, where you could just use Pythagorean theorem. So tangent of R is going to be tan R, or tan of 29, equals opposite is ST, over adjacent is 5. So then ST, then you would take tangent of 29, multiply it by 5, and get ST is about 2.74. If you want to do it this way, that's fine, and you're comfortable with tangent and cosine, I would just use the Pythagorean theorem, because it's a lot easier, and you're not going to confuse yourself. All right, example 4. This is the last example. It's going to take some time. The coordinates of the vertices of triangle PQR are P, -3, 3, Q, 2, 3, and R, -3, -4. Find the side lengths to the nearest hundredth and the angle measures to the nearest degree. So we are finding, again, 6 things. We're going to find angle P, angle Q, angle R, side PQ, side PR, side RQ. So your first step is to plot the points. Okay, so that's what's been done here. Get some graph paper or use your notebook lines to graph these points. So here I've got -3, 3, -3, 4, 2, 3. All right. Now 3 of these are going to be very, very, very simple to find. This is a horizontal line and this is a vertical line. Vertical and horizontal lines make right angles. So angle P is going to be 90 degrees. That one's pretty simple. The next simple thing is to find this length. All of these are units. So when we do this in class, we're going to use graph paper so we can actually count these out a lot easier. So 1, 2, 3, 4, 5. PQ is 5. Same thing with PR. 1, 2, 3, 4, 5, 6, 7. PR is 7. All right, so those are the 3 easy ones. Now we're just basically back to what we did last time. So now we have made this problem the exact one that we just did. Example 3, where we had 2 side lengths and now we don't know the other. Okay, so now I want to find RQ. Again, you could find the angles first and then do some inverse stuff to find RQ. I would just do Pythagorean theorem. A squared, PQ is going to be my A because it's shortest. So 5 squared plus PR is going to be my B, because this has to be my hypotenuse because I just said this was the right angle. So plus 7 squared equals RQ squared. So we get 25 plus 49 equals RQ squared. This gives me 74, so RQ squared equals 74. To get RQ alone, I want to square root it. Now, if we were doing this problem for just whatever, we would reduce this radical, so RQ is 70 squared is 74. We would reduce this if at all possible. But since it told us to round to the nearest hundredth for our sides, we can just go ahead and do that and say that RQ is about, or approximately, 8.60. When you do this in your calculator, square root of 74 is going to be 8.60232527. When you round to the hundredth, even though this 0 is here, you still have to put it. Because if you just put 8.6 in science terms and math terms, this is a lot more accurate than this. And you're going to say, well, it's the exact same number, which it is, but this shows whoever's looking at the problems, say you're like some super fancy scientist and you're doing this math problem for another person, if they see 8.60 as opposed to 8.6, they're going to know that you've rounded it to an extra decimal place. Here you've shown them you've only rounded it to tenths place. They know this is more accurate than this. So again, when it says hundredths, do the 2 points. All right, so now I've got, let me enlarge this again. I've got RQ as being 8.60. Now I'm going to find my angles. I'm going to find angle R. So angle R, I'm going to do tangent again. Tangent's kind of the easy one, I think. SOHCAHTOA. So I'm at R. I'm going to do tangent of R. If I'm here at R, I got opposite over adjacent. And the reason I'm going to do tangent is because I got these nice whole numbers to work with. I don't have to worry about this decimal answer. So tangent of R is going to be opposite over adjacent. So that's going to be 5 over 7. Okay, but I want to get R alone, not the tangent of R. So I'm going to do the inverse. So R equals tan inverse of 5 over 7. And when I do that, I get 35.53767779. And so when I round that, I'm going to round this to be approximately 36. It's 35.5, and that 0.5 tells me to round up. All right, so I've got one more piece of information. I know angle R is about 36 degrees. All right, now, again, you have the choice of doing another tangent, cosine, or sine here, or you can just say that this is 90, this is 36. So take those all the way from 180, and angle Q has to be about 54. Okay, don't worry, we're going to do tons of these fun problems in class so we can get really good at them. So this answer, when they're asking you for all 6, you need to make sure you give them all 6. So again, this whole answer, yes, this whole thing is your answer. All 6 of these. These are the 3 easy ones because you've got a horizontal and vertical line. Starting off, we're just going to do horizontal and vertical. It's going to be very easy to see the 90 degrees. All of these problems will have a 90-degree angle. Now, if it is not on the straight and vertical lines, then you have to figure out which one is the 90 based on perpendicular slopes, which we know how to do that. So that shouldn't be a problem. All right, and then once you find this, I would count these out and then use Pythagorean theorem and then do tangent of one of these and then subtract from the other.